Welcome to Database Management series of video lectures. Today we will be discussing about Unit 1, Topic 9, that is Relational Algebra. So what is an algebra? Algebra is nothing but a combination of variables and operands upon the execution as well as the constants. Upon the execution of this algebraic expression, we get the output, right? So here we will be using variables, which are also treated as operands, and then the constants, right? An expression which evaluates to a final result. So relational algebra here is nothing but, again, the same kind of expression. This expression that is going to be represented in terms of tables or relations is called as relational algebra, right? So here also we will write relation A and B. These two can be treated as variables or operands upon which any operation that can be performed. So combination of these two will result in the output, right? So as we are representing tables here, that's the reason this algebraic expression is called as a relational algebra. So this relational algebra provides a theoretical foundation for relational databases and SQL. Here we try to make use of SQL language. What is relational algebra? The purpose of using relational algebra is to define operators that transform from more than one input relations into an output relation. So let us say that this is a table or a relation A, and this is second table or second relation B. Now I am trying to apply an operation called as addition. Now when you do the operation, the resulting operation will give only one relation or one table. So this is what called as an algebraic expression. So here not only just addition, let us take relation A union B. So here this is input 1 and this is input 2. And this is an operator, right? So an operator which acts upon both the operands, which results in the single output. So this is what called as a relational algebra deals with, right? Taking more than one relations and then converting or transforming into a single output relation, right? Now, let us look at fundamental operators which are there as part of relational algebra. First one is selection. We use a notation called as sigma for selection operator. Second is projection. We use a pi symbol for representing projection operator. Third, union. Fourth, set difference. Fifth, set intersection. Sixth, rename, that is pi. And seventh is Cartesian product, that is x. So these are the various operators that we use for the relational algebra. So let us look at one by one in detail. Now the first operator here is selection. This selection operator is used to select the specific set of tuples or records from the given relation. Now, let us take an example. Here I have a relation with column names A, B, C. The relation here can be represented by R. The table name here is taken as R. Okay. Now we have three columns, that is A, B, C columns. A, B, C columns. Now we have how many tuples here? 1, 2, 3, 4 records we have. 4 records, 3 columns we have. Now I wanted to select, I wanted to select only those records from the relation R, only those records from the relation R. Whatever we have specified within this round parenthesis is nothing but the criteria or the condition for selecting which set of records. So here, our intention is to select only those set of records from column named as C, and the values are greater than 3. So select only those set of records from the table whose values are greater than 3 from the column C. So we will be selecting first, the criteria will look at this. Now, what are the values which are greater than 3? This is 1 and this is 2. So we will be selecting only those set of records which matches to this criteria, right? So that's how you got the output in this manner. That is 1444. So we will be selecting only those set of records which matches with this criteria, right? So this is what a selection operator. Now, next is projection operator. Projection operator, which represents by pi symbol, right? So in the previous example, we have simply selected. So it does not print actually, it just selects those set of records. Now to display it onto the screen, we need to use a projection operator here. Now let us take the same example, relation R table, which has 3 columns, ABC named as ABC, and 4 tuples, 1, 2, 3, 4. Okay. Now I wanted to print. Projection means print or display. Display only column named with B and C. Display the columns named with B and C from the relation R. So we will be selecting only B and C columns from the given table. Now here we got the values 2, 4, 2, 3, and 3, 4. We found 4 records here, but then we got only 3 records here. Now by default, the projection operator removes the duplicate entries, right? So this is the duplicate data which is existing. That's the reason it is being removed from here, right? So this is what a projection operator does. Now, the third type of operator here is union operator. As we already know that union is nothing but appending the content or combining or merging the content from more than one relation together. Right? So now let us take an example. There is a relation or a table named as French and another table or relation named as German. Now let us look at French table here. Here we have two columns named as student name and roll number. So we have the values as Ram 01, Mohan 02, Vivek 13, Geeta 17. So we have four tuples here and two columns here. Similarly, in German table also, we found the same column names named as student name and roll number. And the tuples are four here. 1, 2, 3, 4. Right? They are Vivek 13, Geeta 17, Shyam 21, Rohan 25. Now, we wanted to perform a union operation upon both the tables, that is French and German. Now, let us see here, how do we write an algebraic expression here? I wanted to find a union of both the things, right? So, French table. So, what I wanted to do, I wanted to pick only student names. I wanted to combine only the student names from the French table and student name from the German table. I wanted to perform a union of both the things and I wanted to print it. So, that's the reason we have selected projection operator here from this list as well as from this list. Project both the student names from both the tables, right? So we will be focusing only on this data and this data. Okay. Now look at here. What is the first tuple here? Ram. Right? We found Ram. The next one is Mohan. Fine. Third is Vivek. Fourth is Geeta. And now come at German table. Here Vivek. Already we have an entry with Vivek name. Right? So this record which is duplicate is going to be removed. Next Geeta with a 17. Even this record is also a duplicate one. And the next is Sham 21. So Sham is the name which is selected and Rohan which is also a single entity that has been displayed. So that's how we are merging the content of both the tables by removing the duplicate entities. So this is how a union operator functions. Okay. Now let us move on to the next one, that is set difference operator. So set difference operator, as we have already learned this from set theory, that is A minus B. That means find out the entities from B, remove all that from A, and the leftover things from A have to be displayed. Right? So this is what the concept of a set difference from the set theory. Now let us take the same examples, a French table and German table with the same student name and roll number in both the tables with the same data elements. Now I wanted to print only the student names. So that's the reason projection operator with the student name, column name from French table, subtract it or perform set difference and display only the student names from the German table, right? So we are doing that. So when we are selecting only the names, we will be focusing on this portion, right? Now from here, Vivek, find out is there any Vivek? Yes, remove it off. The next entity in German table is Geeta. Is there any instance of Geeta? Yes, remove it. The next one is Sham. We don't have it, so we least bothered about it. And Rohan also is not a part of it. So we are left with Ram and Mohan. Only those two are going to be displayed here, right? So this is how a set difference operator works in relational algebra. Let us move on to the next operator, that is set intersection. So set intersection will filter only the common things from both the tables, right? So here also we will be considering the same French table and German table with the same column names and with the same data items. So what is common in both the things? Is Ram available in this German table? No. Is Mohan available in the table? No. Is Vivek available? Yes. Yes. Is Geeta available? Yes. Yes. Sham is not available in table French. Rohan is also not available in French table. So the only two tuples which are common in both the tables are going to be displayed. So that's the reason we have written project. Print only the student names from the French table by performing set intersection operation upon the German table of student name column. Right? So this is how a set intersection operation does. And the next type of operator is rename operator. So now renaming means you can change the existing attribute name to a new attribute name. So here we have taken a row A by B of R, which indicates that this is the existing name of an attribute. This can be changed by a new attribute name from the relation R. Okay. So it simply changes the names from the existing table. Now, the last type of operator from relational algebra is cross product. So cross product between any two relations can be achieved by combination of one entity of table 1 and maps with all the entities from table B. So this is how it does. Let us consider this example. So we have a relation named as A with three columns, that is name, age, and sex. And we have three tuples here, Ram 14M, Sona 15F, Kim 20M. Similarly, we have taken another table or relation, that is B. So we found only two records here. We found two columns, that is ID and post. And we found only two tuples here. One is one with the DS, two with the DBMs. So here is the content. Now let us apply cross product of A and B together. So what happens here is nothing but it will combine all the columns first. So it takes first three columns from table 1. All these are table 1 attribute, and this is from table 2, right? So first we start with record Ram, right? Ram 14M will be taken here. and it maps with ID of 1 and DS. Okay. Now again, RAM 14M is mapped with 2 and DBMS. Right. So this is how first record from relation A is mapped with all the records from table B. Next, second record from table A is mapped with all the records of table B. Right. Yes. The third record of table A is mapped with first record of table B and second record of table B. So this is how we get the cross product of A and B. So it does not follow the concept of having same number of columns and with the same number of records. It violates that property. Okay. So this is about various operators in relational algebra. Now let us look at advantages of relational algebra. What are the advantages that we derive? The first one is it completely applies solid mathematical principles. So we are going to follow the underlying principles of the mathematics. Based upon that, the queries are being framed with the help of relational algebra operators, right? So we definitely need a very good mathematical background, and only then we will be able to apply and extend the same conceptual policies even upon to the tables. Now, if we have two expressions for the same operation, and if the expressions are proved to be equivalent, now in that context, the query optimizer will try to find out which query will be taken in order to efficiently utilize the processor time, right? So this relational algebra proves to be an efficient technique that is going to be employed. And then this relational algebra is a high-level language which talks in terms of properties of sets of tuples and not in terms of loops. So technically, it is trying to show only the mathematical concepts, but not in terms of the language-dependent loop structures. Okay, so these are the advantages of relational algebra. Now let us look at limitations of relational algebra. Now, we will not be able to perform any kind of arithmetic operations. So now what kind of arithmetic operations that are going to be done? Let us say that you have table A and B. Now here we have values as 1, 2, 3 and 4, 5, 6. Now I wanted to perform multiplication of A and B. So we are expecting 1 into 4 which should be resulted in 4. Similarly 2 into 5 which should result in 10 and 3 into 6 which should result in 18. We are expecting this sort of operation to be done, but in fact this is not being done by the relational algebra operators. Right? Now the second point is that relational algebra cannot sort. Relational algebra cannot sort or print the results in various formats. So what do we mean by this? To understand in a better way, now to understand that in a better way, now let us take an example of A with 1, 2, 5, B with 0, 4, 1. Right? We have this kind of entities. Now I wanted to perform a sort of A union B. I can do A union B, but then I cannot apply either ascending order operation or descending order operation. You cannot perform this set of thing in combination with relational operators. Right? So that is what the point it means. And then it cannot perform aggregates. Now what do you mean by aggregates? So we have aggregate operations such as now I wanted to find out the sum of the all values from column A and from column B. 5 plus 2 plus 1 gives 8. 4 plus 0 plus 1 gives 5. So this is an aggregation of summation operation which is applied only onto this column of data. Right? Only to that column of data. So this sort of operations cannot be done using relational algebra. And the next point is relational algebra cannot modify the database. Yes, it does only the operation, but then the underlying data which is being stored in the memory will not have any impact. Only for the presentation purpose, we do that operation. And then finally, relational algebra cannot compute transitive closure. What do you mean by transitive closure? Now, with respect to a theory, set theory, let us say that A has values as 1, 2, 3. And B is another set which has a value of 4, 5, 6. What is closure property? 1 and performing any kind of operation of 4 should get the result or the output which should be from any of these two sets. Okay. So if I have done 1 plus 4, then it should, if it is resulted in 5, make sure that it should be belonging to any of this set. That is what a closure property means. So you take any number, any real numbers or the whole numbers which should ultimately belongs to the real number. Right? That is what the closure property tells. And what do you mean by transitive property? Now with respect to transitive property, you can write 1 to 4 can be taken as one pair of coordinates, 2 to 5, similarly 3 to 6. Right? So in this context, you don't find a transitive property here. But when we take an example of 1, 2 and 2, 5 and 5, 7, if we have the pair of elements in this manner, 1 to 2 and 2, 5, which takes you to 1 to 5. And then 5 to 7, a combination of these two can lead to 1 to 7 pair of elements. So this is what called as a transitive property and the closure property. A combination of these two cannot be supported by the relational algebra. So these are the limitations of the relational algebra. Thank you.